Hey everyone. So today I'm going to speak to you about one of the most notorious services, or actually system, that I had to work with during my career. It actually gave us non-stop headaches, and it was single-handedly responsible for over 60% of our support tickets, production incidents, and performance issues. Sorry. So we are going to deep dive into the architecture of the system and the reasoning about why we actually had to build such a system, and then how we evaluate it over the years. So just a bit before we start, let me introduce myself. So my name is Yonatan Karp-Rudin. I just started my new challenge as a senior backend engineer at Billie about a month ago. I'm extremely passionate about knowledge sharing, which led me to do what basically any other developer in the world is doing, which is starting a blog. Well, I'm focusing mainly about Kotlin and the implications for backend, but not only. And besides that, I'm extremely passionate about functional programming and event-driven architectures. However, that would be very slightly reflected in today's talk. Okay. So let's look at the agenda for today. We'll have multiple steps. Each step will reflect a different light on the system and will reflect on the different challenges and the different solutions we have to those challenges over the years. Well, we will start with an introduction. The introduction will give you the context of why we built the system, what was the reasoning behind it, what have been the capabilities of the system, and what have been the weaknesses of this system. Then we will deep dive to the actual system design. We will talk on the different components. And again, we will focus on what each of those components have been supposed to do within the system. Next, we will address the flaws in the system. We will talk about the major flaws and what was the implication on the system itself. Then we will talk about the human factor. We will talk about how stuff like lack of ownership and priorities have impact on our architecture. Yeah. The next step would be new feature and new challenges. In this step, I will basically talk to you about new feature requirements that we got and how we integrated it into the system and what was the challenges that we faced and the unexpected issues that we had with it, which directly take us into the performance issues. We had quite a lot of performance issues after we introduced a new feature, and then we can deep dive into specifically what have been those issues. And then we will talk about, well, a path to a better solution, or what we did to improve those horrible performance issues. We will talk about how we managed to actually reduce dramatically the performance of our database by reducing the CPU and the memory usage, and improve the availability of the feature by over 450% after applying this solution. And then lastly, we will talk about the road ahead, or in other words, the future of this architecture. So let's deep dive. All right. Then let's start with a bit of history. The story doesn't start too long ago. It starts when I joined one of my previous employers about 5 years ago. I joined the company, and my manager at the time introduced me to one of those services that the team has been responsible for. And my manager came and he was like, well, this service is a temporary solution, right? That come to solve one of those technical issues that we have. And we are hoping that in a couple of weeks, maximum couple of months, we will remove it, right? And I guess that everyone here had this temporary solution and you know what's going to happen, but indeed, 5 years have passed by and this service still running in production. So, yeah, I would like to actually show you the system itself, and then we can maybe have a look at what actually caused us to start this evolution and why we end up in this situation we've been in. So let's look at the system architecture. The most important thing to know is that we have 3 major players in this architecture, right? Each one of them serving a very important part into the system. We will deep dive in any of them, every one of them, and then we will speak about the responsibilities of them. So Let's start from the upstream service, right? The upstream service in this context is a bit of an odd service because it was not managed by my team. It was managed by a different team, and it was completely out of the domain of my team, right? The responsibility of this service is basically to process data and store it into what we will call in this presentation the source database, right? What is important for you to know is that the data in the source database is not stored only in a final state. It actually stored in initialized state. Then it might be updated to an update state and go into the final state, right? And this can go between seconds to hours, depending on the context. Next, we have the poller. As the name suggests, the main idea or the main job of the poller is to scan the source database, check for new data, aggregate the data, and then store it into what we will call the aggregated database, right? Please note that this behavior of polling, aggregating, and storing to the database is the main activity of the entire system, right? We will focus mainly on the poller in the rest of the presentation. Next, we have the reader service. The reader service is basically the entry point for our users. Our users will communicate to the reader will access the aggregated database, fetch the aggregated data for them, and serve it to them. Well, that's the best case, right? So this solution looks fairly simple, right? What can go wrong? Well, the devil is in the details. So let's have a look. We will focus mainly on the poller and the upstream service. We have four major flaws that I will discuss during the presentation. Well, the first one is related to the upstream service and the poller service. They are both sharing the integration via the database, right? That means that if, or actually when the upstream service would change anything, either in the service behavior, the data behavior, or the structure of the database, the poller will misbehave, right? Because it either fetch wrong data or fail to perform at all, which will, as a result, will cause us to store aggregated data in a wrong way, or again, fail completely. The second part is related to how the poller was actually implemented. Since the poller is scanning the database only for new information and it scans it only forward, if by the time that the poller scans the data is not finalized, the poller will ignore the data completely, right? Which means that it will be missing from the aggregated database. Yeah. Yeah. Not only that, but because we are using a poller, it means that we cannot have the data available at real time, right? We can have it at polling interval at best, which in theory should be every couple of minutes, but in the worst case and in some edge cases can go to hours. Lastly, the poller was implemented using a cursor, meaning that it stored the last row that is scanned and then fetched the data from the database in order to know in the next interval where to continue from. Because of this behavior, we couldn't have more than one instance of the poller in our system because we might have a race condition between reading and writing from the database, which meant that if anything happened in the poller, the entire system was crashing and we couldn't fetch any information. So that wasn't ideal, right? The system was built with good intention, but yeah, it didn't perform well. And that happened for a while. Well, the good news is that after some time, we had some hope in the horizon. The team responsible for the upstream service decided to go with a different approach. And instead of us probing their database, they started to publish some events that basically describing what happened to the entities in the database. So instead of us going to the database and trying to fetch the information and figure out what's going on, they send us events like this entity have been created or updated or finalized, right? This was literally a game changer. However, it didn't come without any problems because those events that have been published by the event publisher use the external IDs of the entities that have been stored in the database, which make perfect sense for them. But both the reader and the poller have used the internal IDs, because of the high coupling to the database, right? So you can basically think about it as if they are speaking two different languages and cannot understand each other. So we sat down and we tried to figure out what we can do to actually improve the situation. And what we decided to do at the end is the following. We consume the events from the producer. And then if the event mentioned that the row was finalized, we store the ID into the aggregated database. Then we have a table which basically presents all the entities that are in a finalized state. Then the poller kicked in and basically did exactly what it did before. It scans the table of finalized rows, took the IDs, and then used external ID in order to fetch from this data source the information with the internal IDs, right? Aggregating the data and continuing, just like before. Just by doing that, we improved a lot the stability of our system. Because now when the poller walks, we actually know that the row have been finalized, right? We will never skip a row again from the database. So that was kind of nice because the system kind of worked now, right? We could see immediately that we had a drop in the support tickets. Clients complained much less. Amazing. However, this change didn't come without any problems, and there was some hidden danger that we didn't thought about. Exactly because the service was kind of working. Okay, sorry, let me come back. So it was very clear to everyone in the company that this solution does not scale, right? And it's kind of a band-aid solution. And it was very clear to everyone in the engineers, from the senior developer and until the VP of engineering. However, because the solution was kind of working, it was deprioritized again and again in the team, and the team had to focus on different things. Not only that, but the team and the company restructuring caused the system to move between different teams inside the companies. Well, each time this system has moved to a different team, you could see that the understanding of the history of the system and the reasoning behind it and the challenges that it's facing are kind of disappearing. You can think about it like telling a story again, right? Every time you tell the story, some of the details are kind of gone. I would add here that on a more personal note, I myself had the opportunity to work on this system twice in two different teams. And I could notice that the drop of understanding, maintainability of the services, and people that are just too afraid to work with the legacy system that they don't understand. That gave me kind of a unique perspective about how this human factor had an impact of something that is purely technical, and we usually don't think about. All right. Then some time passed by, and our product manager came with a new feature. This feature was relatively simple, and I will describe the requirement in a second. But I would like to explain that it has some complexities that are kind of hidden. So the requirement that we have are as follows. Every day, we need to create a report for all the entities that have been finalized by that day in the source database, right? That means, it's important to note, a day considered to be closed at 5 a.m. At the time of the client, right? So if we have multiple markets, depending on the market, the client would expect the report to be available at 5 their time. To implement that, what the team decided to do is as follows. We had a service that's called the daily management service. What it was responsible for is to, opening a day and closing a day, and then maintain IDs per day for the client once they enabled the feature. And how it worked, it was as follows. The client called the reader service. The reader service triggered a request to the daily management service, telling the service, please enable the feature for this client. Then the poller doing its polling by batches, fetch information from the source database, send a REST request to the daily management service and ask, what is the IDs for those clients? Get a map back of client ID mapped to their ID, connecting the dots, and storing it into the aggregated database. That's fairly simple again, right? However, this design still have a few flaws. First of all, we have a tight coupling between the Polar service and the daily management service, right? That meant that every time we had to shut down the daily management service for maintenance, database upgrades, whatnot, we had to shut down the Polar as well. And the reasoning for this is that if the Polar consumed information from events while while the daily management is down, it will not assign the day ID into the rows. And then those IDs will miss from the report, which will by itself causing us to get more support seekers. Not only that, consider that the daily management is quite busy in specific hours in the day, right? By closing and opening the new days. But the rest of the time, what it actually does is just answering the question, what day is it, right? Lastly, as it's quite easy to see from the diagram, the ownership of the feature is spread all over the system, right? The reader is the one responsible to enable it. Then some of the feature is managed by the daily management. Some of it is managed by the Polar. Then we connect them in a weird shape and store it into the aggregated database. So let's look at a possible solution for this. So instead of doing what we did, we could switch the way of connection. And instead of the Polar calling the daily management service, the daily management service can now publish an event saying for whoever is interested, hey, this client opened a new day, or hey, this client closed a day, right? Then the Polar can consume this event alongside with the events coming from the event producer, aggregate them together, and store them into the database. Not only that, but even if the daily management service would be completely down, the Polar still have the day ID locally, and it can continue to work without any problems. When I asked the team why they decided to choose those approach of using REST calls, I got an answer that, in my opinion, reflects a lot on those temporary long-term solutions, and it was well, it was simpler, and we will refactor it later. So yeah, we decided to go with the REST implementation. We decided to go to one of our core markets. We started by rolling out to 100 clients. We monitored the system for a couple of days. Well, it was okay. Then we've been kind of encouraged by this success. Then we decided to roll out to another 1,000 merchants. But this time we decided to go with the biggest and most active clients that we had, right, in this market. It didn't take more than a couple of days before we could start to feel the stress on the system. And then we started to get alerts and timeouts and whatnot. And we started to investigate what's going on. And then quite fast, we figured out that the problem was that when the reader service is going to the aggregated data and trying to fetch the report, it's doing a very complicated query that contains many joins, which, as you can imagine, is very imperformant. So as a result, what happened? We sat down, we tried to think, and then one of the engineers came up with an idea. What if, since the reports need to be refreshed only at 5 a.m., what if instead of calculating every time, we will pre-calculate them using materialized view, and then let the reader service just fetch the information? Well, I want you to remember this because this will have the impact until almost the end of the presentation. So let's look at the solution that we decided to go with. Actually, before, let me explain what materialized view is. So the people who don't know what materialized view is, right? You can consider it as a virtual table, right? However, unlike a table in the database, in materialized view, when a new data inserts into the database, it does not refresh automatically in the materialized view. In order to get the newest information, you have to refresh the entire view. And that means that you need to recalculate all the information that you had in this view, including the data you already calculated, right? So the solution we had to go with was as following. Every day we had kind of a cron job in the Polar that waited until 5:30 at our market, assuming that all the days have been closed by all the clients. Then the Polar will start to refresh materialized view in the background. When the view is finished, we delete all views, insert the new views, and everyone is happy. And now you might asking why you have to create it in the background and not just refreshing the view, right? So this operation was quite heavy. And by quite heavy, I mean, it took at least 20 minutes at the beginning. And what happened is that if a client tried to access the materialized view, it will lock the connection to the database because the database will wait to the materialized view to finish, right? Since we had only 20 connections to the database, after 20 calls, the service will be completely out and just waiting for the materialized view to finish. Yeah, so that was the solution, and I would like to go a bit to a visual example so you better understand what's going on. So let's consider this example, right? We have different data in the database. The blue data is the data that we already had in the days before. We calculated, it's in the materials view. The yellow data is the new data from the current date that was just finished. Now the Polo starting to refresh the view. What happens is that, well, we take all the data and refresh it again, right? Not ideal. Yeah. So, yeah, this situation continued for a while. So at the beginning, as I mentioned, it took between 20 to 30 minutes. It wasn't ideal, but it was kind of manageable. It was okay-ish. We knew that we had to fix it. It was, well, yet another temporary long-term solution. And we just, okay, yeah, fine. However, the turning point came, okay, we had more clients enabling the feature, right? And as I mentioned, the more data we have in the materialized view, the longer it takes, and the more clients and more data we have, we get to the breaking point where the refresh took 5 hours on average, and in some cases between 8 to 10 hours, right? This have direct impact on one of the core requirements of the feature, that it should be available at 5 a.m., right? As a result of that, we decided to stop the rollout and not roll out to other countries until we will fix the feature, right? Which have direct impact on the product itself. Not only that, as I mentioned, the materialized view is extremely heavy on resource consumptions, both CPU and memory. And since the second we started to do it, we started to see every morning alerts raising because the database was super busy focusing on stuff which is not real production traffic, right? Not only that, as the data grew and the refresh took more and more time, we started to see failures on the refresh itself because the service just consumed too much memory. That meant that in practice, in some cases, the data was not refreshed, right? And we started to get complaints from clients that the data is incorrect or incomplete. And it was refreshed only in the next day when the materialized view was refreshed again. If you are asking why we didn't trigger a new refresh after the refresh failed, is again because the refresh takes between 5 to 10 hours. Yeah. Well, let's talk about the situation. So this situation started for almost a year, right? We knew that there is a problem. But the team had to focus on different parts of the domain because of other priorities. Yeah. And one day, one of my colleagues actually came to me and he was like, I think that I have an idea how to fix the issue, right? What if instead of using this materialized view, we just calculate the data since the last time we scanned, right? And then we take this delta and store it into a permanent table. And then in the next scan, we will take yet another delta, calculate it, and store it to the permanent table. And we will continue this process again and again, right? So the idea is basically that we have shorter iterations that are much quicker and much less resource consumption. And even if for whatever reason we will fail to update, right? Then the next iteration, which would be much, much quicker, will pick up and continue. Let's look at the visual example to get to understand it better. So here, let's consider each of the color basically a different time that the data arrives to the database, right? So we have the blue data, which arrives at the first scanning of the Polo. Then we are taking the data, we are calculating, inserting into the view, then taking the information from the view, copying it into the constant table. Then the poller starting the next scan. Now it takes only the red data, inserting into the view, and the constant table, right? Lastly, the third iteration, again, we are taking only the yellow information, materialized view, constant table. Amazing. So while we are kind of thinking about how to implement it, we kind of figure that we actually don't need the materialized view. We can use the SQL query and insert it directly into the table, right? So yeah, here, drop the materialized view, save a bit more resources, amazing. We found a way not to only make the system less complicated, but also save a bit more resources. Yes, okay. Now, let's talk a bit about the impact of those changes. So first of all, the code was much simpler, right? We reduced a lot of complexity from the code base. It was much more easier to reason about what's going on there. New people could figure out what's going on. Yeah, the complexity, the mental cognitive complexity was much lower. Secondly, the refresh was much faster. The interval was about 3 seconds, which meant that we could refresh the data every minute into the permanent table, right? That meant that finally we've been in the case where we met the requirement that the report is available at 5, right? As a result of that, we finally could enable the feature in new countries. That was kind of amazing. And maybe the most important one, well, we reduced dramatically the usage of CPU and memory, right? And as I mentioned, reduce the amount of time until the feature is available by at least 450%. What's important to say is that this entire process took us only 6 hours of work, right? So we worked for 6 hours. We got a bit of help from the database admins. We developed it, pushed it all the way to production, and we saved it in less than the time that one refresh took. All right, let's speak a bit about the road ahead. So I kind of spoiled it at the beginning. I'm no longer working this company, but yeah, a group of really talented engineers still working on the problem, and they are currently working on a new system that will replace the existing one. Well, let's speak a bit about the characteristics that here. Sorry. Let's speak about the requirements from the new system. So basically, this system would be driven by events coming from the upstream service, right? No poly mechanism, right? This is a huge no-no. We want the system to be much more scalable. So we cannot rely on services that have a race condition between them. We want to have high availability. Not only that, the solution should not only solve the problem that we have today, but it should be in a situation that allows us also to solve the problems that we might have tomorrow, right? Yeah, that's... Yeah, I think that I spoke a bit fast. All right, then I will slowly conclude, and then I think that we'll have quite a lot of time for questions. So what did we talk about today? We started from talking about the original system architecture, right? We talked about the tight coupling that we had between the two services of the upstream service and the poller via the database. We spoke about how this is a terrible idea and you shouldn't do it. Then we spoke about how you can leverage events in order to move away from integrating via the database. We had a talk about the human factor and how stuff like ownership and priorities in the companies have impact on your architecture, right? Then we talk about the new feature that we had to integrate and how, again, coming up with temporary solutions have direct impact of your system. Then we spoke about how using the wrong solution for your problem in the sense of materials you can create performance issues that you might encounter for a very long time, and how we manage at the end to apply a very simple solution to improve dramatically the performance of the service, right? For me, the only thing that I want you to take from this presentation, because obviously this system is not what I want you to take from here, is to always evaluate your architecture, right? And check if you have places that you can improve it, because this is what we try to achieve over time, to improve the architecture, right? And the most important thing is that you should evaluate the assumptions that you have on your architecture, because whatever you assume today might be proven wrong tomorrow, right? So, first of all, I would like to say that everything related to today's presentation with a bit more detail is available in my blog. So if you want, you can scan the barcode and go directly there. Secondly, if you want to talk, I'm available on networks. And thirdly, thank you very much for listening, and I'm open to any questions you have. Any questions?
I actually have a question. Like in the now they can show us the first point was that fact that is inevitable. What precisely do you mean by that?
Well, what I mean is that even if you build the most correct system that you have, it might not hold to whatever your requirement will be in a few years, right? So no matter what you decide, if you cannot build the perfect system for all cases, right? Because you might your company might scale in clients, or you know what I mean?
Yeah.
Yeah. So even the perfect solution most probably won't hold for more than 5 to 7 years.
So to me, that does not imply necessarily that, like the fact that a system needs to adapt doesn't mean that at every iteration it becomes that to me. So,
I guess it's arguable, but for me, everything which does not perform well in your system is a tech debt.
okay.
Yeah. Any other question, including why did you decide to do any of this? Yes.
Third question. When you wrote about the final solution that you have found for that, that solution didn't make problematic the data redundancy between the two databases. I mean, at that point you had basically the source database, okay, and you had another database for every client. If I didn't meet.
No. Maybe I didn't explain correctly. So how it works, we had the source database, which contained the data, right? Then we had another database, which is basically, if you listen to Olga's presentation from before, it was basically a projection of the source database, right? Which was aggregated data in a different shape in how we want it, right? It wasn't per client, it was just an aggregated data of the source database enhanced by some information such as the day ID.
Okay.
Anything else? All righty. Thank you very much.